Hello again. Today we're going to be switching gears a little bit, and instead of talking about direct variation, we're going to be talking about inverse variation. So let's get started. We do need to define a couple of things. We're going to say that two variables can be inversely proportional, and I can write it as y is proportional to 1 over x. So what that means is instead of the two variables dividing to give the same constant, now they multiply to give the same constant. And I can write that as x times y equals k, or if I wanted to solve it and create a function of y in terms of x, I could write it as y equals that constant k over x. And that relationship would be the same for every x-y pair in that relation. Again, k is called the proportionality constant. And so if I graph y equals k over x, it's not going to look like a line like it did for direct variation. It's going to look like a hyperbola. That hyperbola is going to have both a vertical asymptote and a horizontal asymptote. So let's look at an example. Mary wants to know how long it will take to walk 6 miles. So she makes a table showing what her speed will be and what time it will take to walk that 6 miles. So we're going to sketch a graph of this relationship, just graphing each ordered pair one at a time. So the point where speed is 1 and time is 6, that goes at that red dot right there. The next point is 2 and 3, then 3 and 2, then 4 and 1.5, 5 and 1.2, and 6 and 1. So you'll notice that this is not linear and it does not go through the origin. It's actually going to be a hyperbola. Okay, we can also use this type of relationship to find missing values as long as we set it up correctly. So if I know that two variables are inversely proportional, and I know one of the xy pairs, and I know one value from another pair, I can find that missing value just like we did with direct variation. We're just setting it up differently. So here's an example. If I know that y is inversely proportional to x, which I write as y is directly proportional to 1 over x, and if I know that x equals 5 when y is 24, what is the value of x when y is 60? So since they are inversely proportional, I'm not going to divide them and set them equal to each other. I will multiply each pair and set those equal to each other. So I will plug in what I know. The first x is 5, the first y is 24, and the second y is 30, and I'm figuring out what the second x is. Okay, and if I do that and I solve the equation, then I get that x would have to equal 4. All right, so that is some of the applications of using variables that are inversely proportional. If you have any questions, please let me know, and I will see you tomorrow.